Okay, this is Mr. Kusaj. This is part 2 of chapter 2-4. Again, don't forget the date up here. So in part 1, we talked about how you can get all the possible rational zeros by looking at the beginning of the polynomial and the end, the first number and the last number, and the factors and all that. Okay, that's what we did in part 1. In part 2, what we can do is narrow down the possibilities. Remember that last one had a bunch of possibilities? Well, we can do something else to narrow down the possibilities. So notice in this little graph here that all the zeros are between A and B, right? These are zeros, and they're between A and B, okay? Now, if that's true, then we call B the upper bound and A is the lower bound. So between the lower and upper, everything is in here. But here's a question. How do we know that the graph further down the line somewhere won't come back down for another zero? How do we know that this really is the lower bound? There are no more zeros below this x and above this x. How do we know that? Well, we can check. Here's how. It's called the upper-lower bound test. And what you do is you take any number here and here, right, that you suspect are the lower bound and the upper bound, and we're going to check. Okay? So if this number is in fact the lower bound, then all your answers are going to be switching signs like this. Negative, positive, negative, positive, negative. If that happens, then you're dealing with the lower bound. Okay? Then you do it with positive C, positive the number, and then if you get all positive here, then you're dealing with the upper bound. I'm sorry. So once again, you do the synthetic division, and if you get alternate signs, you're dealing with the lower bound. If you get all positive, then you're dealing with the upper bound. So we say, oh yeah, negative C, that's my lower bound. C is the upper bound. All I have to do is take all the numbers in between, all the zeros in between. There are no other zeros. Okay, here's an example how this helps us. Here's an example of how this helps us. So here's this long polynomial, right? Long polynomial. And we do the possible zeros, right? The factors of 2 go on the bottom. The factors of 24, which are many, go on the top. And a positive, negative for each one of them. Can you imagine all the possibilities? Look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Positive, 10 negatives. So that's 20 possibilities. They're possibilities, right? They don't all work, but they possibly work, right? So how do we narrow this down? Well, we graph it, right? We check the graph, and then we notice in the graph that the graph fits between -1 and 7, right? But how do we know that there isn't more, right, on this end and on this end? How do we know? Well, we can plug in -1 and 7 and see what happens, right? So we plug in -1 and we do synthetic division, get all these answers, and you say, hey, look, it alternates. Positive, negative, positive, negative, positive. How about here? Right? You do the synthetic division with the 7, and you get 2, 3, 20, oh, look, all positive. Right? So what does that tell you? That tells you that all the zeros are going to be between -7, right? So can 8 be a possibility? Well, it was until we checked it. 8 is past 7, so it can't be a possibility. 12, 24 can't be a possibility. Positive half, it's in there. Positive 3 over 2 is negative 3 over 2. Negative 3 over 2 is -1.5, not in here. So the point is, oh, I did it again. The point is, we checked -1 and we got alternate, right? Positive, negative, positive, negative. We know that's the lower bound. We checked 7, all positive answers, right, in synthetic division. So now we're sure that all your answers have to be between these two between these two numbers, right? Remember, right? It's like A and B are upper and lower bound, and now we're sure there's no more zeros this way, there's no more zeros this way, right? So now anything that's outside of -1 and 7, you can throw out, like 8 and 12, etc. Anything outside of -1 and 7, you can throw out. So we narrowed down the possibilities. We had a lot of possibilities, but we narrowed it down. Okay? That's the upper-lower bound test. You need to check the graph, right? You graph it really quick, and then you see that, hey, I don't see 12 there. Well, maybe it's not supposed to be there. So what do you see? Well, I see -1 and 7, so you check between -1 and 7. We'll talk about this in class more. Okay. Just by looking, no synthetic division, no division, no long division or anything. Just by looking at the polynomials, there's a rule of signs. That's all you do is look at the signs, and if the following happens, then you have more information about the zeros. Okay? Now, suppose you have a long polynomial. Well, if your signs switch like this, that's significant, because if it switches twice, then you have 2 positive zeros, or maybe 0 positive zeros. Okay, just keep focusing. You'll see the pattern. What if you have 3 sign switches in your polynomial? That means you're going to have 3 positive zeros, or maybe 1 positive zero, one of those, right? Notice that it goes down by 2. So you start with how many switches you have, and then the next possibility is 2 down. So whatever this polynomial is, it's going to have 2 or 0 positive zeros. Whatever this polynomial is, it's going to have 3 or 1 positive zero. It's not going to have 2. It's not going to have 0. It's 3 or 1. See, we're finding more information just by looking at the polynomial. What about this one? 1, 2, 3, 4, 5. So you could have 5 or 3 or 1 positive zeros. Wow, they're all positive zeros. Well, there's a way to check for negative zeros, right? Negative intercepts. Remember what 0 means, positive 0. You know what 0 means, right? The intercepts. So all these are on the positive side. Well, if you plug in negative x, then you can find out how many negative zeros you have. It's the same rule, right? So 1, 2, so you can have 2 or 0 negative zeros, right? Because we're doing with negative now. Let's look at an example. Here is a polynomial. Can you tell me how many positive zeros and how many negative zeros it has? Well, all you need to do is look at the sign. So this is switch, switch, and that's it. The sign changes twice, right? So there's going to be either 2 or 0 positive zeros. That's it. We're done. I have some information about this polynomial. I know that it's going to have either 2 or 0 positive zeros. What about, does it have any negative zeros? Well, let's plug in negative x, right? Plug in negative x. There it is, there it is, there it is. Now you got to be good with signs. So negative, 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 negative is positive. Negative, negative, positive is positive, right? Negative, negative is positive. And then negative, negative is positive, and this is negative. So what do we have? Just one switch. One switch. So that means 1, negative 0. Right? I know it seems like a lot. It seems like what the heck is going on? But all we're doing is seeing different ways of looking at a polynomial and finding out things about it. We can find out how many zeros it has, the possibility of how many zeros, how many positives, how many negatives, between what number and what number. That's what's going on here. Okay? So again, we'll do more in class, but there's definitely a pattern going on here. Okay. The last thing, what if we give you the zeros? We're not asking about what the zeros are and long division, all that. We give you the zeros. Can you write the function that the zeros work with? This is easy if you know how to multiply in algebra, the FOIL method and all that. So the example is you're going to write the function, the polynomial, for these zeros, right? If x equals 3, x equals negative 4, x equals 6, x equals negative 1. So there's some graph out there that has these x-intercepts. What would be the polynomial that has those x-intercepts, right? Well, let's work backwards. These x's come from these factors, right? Right? Remember, equal to 0? So if this is equal to 0, then x is 3. There it is. So now we're going backwards. So these give you the factors. Now that I have the factors, what do you do to get the big number that the factors make? You multiply. So this times this times this, then those two answers. So you got to be really good at multiplying. Let's see how I tackled it. Yep, that's how I did it. So these two get multiplied, these two get multiplied. Now I have to multiply this times this. How do you do that? Well, basically the rule is each one of these with all three of these. So this one times all three, this one times all three, this one times all three. Time consuming, but easy. So x squared times everything, x times everything, and negative 12 times everything, right? I got all the answers. I combine, and there it is. Let me pull it up. And there it is. This polynomial comes from those factors we saw up there, right? This polynomials come from these factors, right? So imagine if I asked you, oh, look at this. Can you find the possible zeros? Look at the 1, look at the 72. Can you find how many positive, how many negative, all that, right? So we would talk about finding the zeros. Well, now we're doing it backwards. We gave you all the zeros. You give us the polynomial, okay? So for the try problems, use the rules of signs to describe the zeros, right? The switching of the signs for this polynomial. Positive, how many positive zeros, how many negative zeros. Then write a polynomial, like this last example, write a polynomial with these zeros. Okay? Switch them to factors and then multiply all the factors, all three factors. So this is easier. There's only 3 of them here. Okay? All right. See you in class. Bye-bye.